Good morning, Algebra 2 students. This is Miss Taz coming to you from Baldwin, Maryland. We are going to be going over two things today. This is part one video of key characteristics of sine and cosine graphs. Part two is going to be writing the equations of sine and cosine graphs. So here we go. All right. So you are going to want to be taking some notes in your interactive notebook and write this all down. So feel free to pause at any time to catch up. So a basic sine function looks as what you see on the screen. And this is something in which A, B, C, and D are all forms of transformations. And so we're going to be kind of going through finding the A, the B, the C, and the D. I'm really not going to focus on C right now, and we'll see if we get to that later, okay? So first thing A, the absolute value of it is going to be, like it's already messing up, A is going to be the amplitude. This is the height from the center of the function. The amplitude, we discussed this last week. B is considered the number of periods or cycles between 0 and 2 pi. This helps you calculate the period, the actual period, which is the formula that you see there. Period equals 2 pi divided by b. So b is actually the number of periods, the period being one full cycle of the curve before it starts to repeat. Okay, next we have our C, which is called the phase shift. It's the same thing as your horizontal shift, which moves in the opposite direction that we are used to seeing, just like all other functions. And lastly, D is our vertical shift. Okay, cosine graphs work the same exact way. They are really no different, except for you will see a sine instead of a cosine. So let's go ahead and start taking some notes. So we're going to do each one individually. All right, and so let me just make sure that I am using the right colors as I go through. Pretty sure I have to do that. So that's a blue, red, green, purple. All right, we'll see if I can keep up with that. All right, so we're going to start off with our blue. So we are finding the amplitude. Amplitude, again, is your absolute value of A. And so as we are looking through, we are trying to determine how tall the graph is from the center or how short, and it's the same thing. So if I kind of go through and I go, okay, well, this is all the way up at 1 and its horizontal center is here at 0, that means that our amplitude is 1. We can also see that between the horizontal center and the bottom of the graph, this is also a distance or height of 1. Remember, height can't have a negative, and so our amplitude is 1. Okay, for number 2. Number 2, this is the height right here goes up to 1. You can't really see it, but there's a 1 over there. And then the horizontal center is here. So we can see that our amplitude is again 1. So our amplitude is 1. Moving down to number 3. Here's our maximum. And you see that I have red dots marked on every graph. This is to show you the beginning and end of one period. So one full cycle, all right? And so that kind of also guides us to where the center of the graph is. So if I take a look at this one right here, here is my center of my graph. And so my height here, my amplitude, if we look at it, is going to be 1, 2, 3, 4. So my amplitude is 4 for this one. So my absolute value of A is 4. All right, and our last one. So here's our height, our horizontal center, and so then our amplitude here, if these are counting by 2's, this is 4. So our amplitude is also 4 here. So absolute value of A equals 4. All right, okay, next. This is a little bit harder. So we're going to be looking at the period or the B value. So all four problems, I'm taking the same four problems and doing each part of them. So the period is one full cycle. So we can see that this curve right here is going from here and it's looping and stopping at 2 pi. So I can already see what the period is. So my period is already going to equal 2 pi. So I need to solve for my b value. So the b value uses this formula up here. So I'm going to set the period of 2 pi right here equal to 2 pi over b. So that means that I have the period, here's my formula, equals 2 pi divided by b. So this formula, this period is going to go right there, and then I'm going to solve it. So 2 pi equals 2 pi divided by b. Now, if you're kind of savvy, you can go, well, duh, look at that. What would this number have to be the same? And that would be 1. There are going to be some that we have to actually go through and solve, but for right now, this is pretty straightforward, which means that our b value is 1. You need this information to be able to go through and write the equation, which we will do in part 2. So both of these are information that we need for this. Now we can look at number 2. This whole curve also ends at 2 pi. So it's going in between 0 and 2 pi. So then we don't really need to do any work because we just kind of went through and did that. And our period is 2 pi, which is going to indicate to us that our b value is also 1. Okay. All right, next. Problems 3 and 4. So you can see 3, if you take a look, it starts again at an x value. These are off a little bit, but this is my x value of 0 all the way to my x value of 2 pi. So super easy. One more time. So then our period is 2 pi, which indicates that our b value is 1. So all of these are very similar. Now we look at the last one here, and we can see that if we take a look at this, this is starting, it's starting here, and I marked the red, and this is ending at pi over 2. So our period now is pi over 2. So we're going to have to do some actual work. Oh, get away from that. There we go. So our period now is pi over 2. So I'm going to set that period equal to the formula up here equal to 2 pi over b. Oh, we're going to have to do some work. Okay, so I'm going to cross multiply. So if we cross multiply here, then we're going to get pi times b equals 4 pi. And now to solve for b, we will divide by pi. So if I divide by pi, that's going to end up with b equaling 4. So here's the two pieces of information that we need for this. Okay, so what this 4 is telling us is that if I continue this graph all the way out to where 2 pi is, then I would actually see 4 of these. I would see 1, 2, 3, and 4. I would see 4 actual periods or cycles between 0 and 2 pi. That's what this 4 is telling me. Okay, moving on. Phase shift. So this is just a horizontal shift. Looks like I forgot a parenthesis up there. But because the horizontal shifts, if you start putting those in there, it starts messing things up a little bit. And so I really didn't give you any in these examples. Every one of these does not have a horizontal shift. So all of these, the horizontal shift would be 0 or none for every single one of these. A horizontal shift means that the graph does not start at 0, 0. So for instance, if I took this graph and I maybe started here instead, and we went down like so, and kind of went like this. If I did something like that, then my horizontal shift for this example would be that it moved right pi over 2, and that would be shown in the graph. Okay. I will be putting some challenging problems up for those that are like, these are pretty straightforward. I want to try something harder. So you can try those later. Okay. All right. Last part of this video is the vertical shifts. So vertical shifts take from your horizontal center, and it looks to see, does it move up or down? So if I take this, the way that I can tell is I can take my horizontal centers, and from the horizontal centers, you keep seeing Miss Haley popping up, don't you? From the horizontal centers, we see where it is. And so we can see in this first one, my horizontal center is at 0. Number 2, it's at 0. Number 4 is at 0. So all of these 4 have a vertical shift of 0 or none. So this one, and this one. Now this one down here, we can see that the horizontal center is now down at -2. So this will have a vertical shift of down 2 or -2. All right. I know this is almost 12 minutes. I was trying to be quicker, but sorry, just isn't happening. Please check out video 2 to start writing equations. Have a good day.